Around 40% of the European population is concentrated in coastal areas. Mediterranean coasts are then a very important source of revenue, but in order to keep obtaining the economic benefits, a well-preserved environment is required. But it's important to be concerned of the main issues that generate coastal degradation, to come up with the proper solutions to deal with the related problems. We have two main aspects regarding coastal degradation. First, we have the issue of coastal erosion. Secondly, lagoons and sea pollution. Coastal erosion is a natural process, but when human activities are involved, this can increase the negative effects. An important erosion factor is the alteration of the sediment regime, which is mainly caused by the interventions at river basins and coastlines, as well as urbanization. In relation to water pollution, the quality of the water is directly related to flora and fauna habitats preservation. So whenever there is a bad sewage management or a high touristic pressure, the wildlife is going to be affected.
Since humans are part of the problem, it's our responsibility to take measures to prevent and to solve these issues. As prevention measures, raising public awareness and knowledge is important, as well as the development and respect of proper regulation. In order to rehabilitate the degraded coast, well-designed projects, such as those focused on keeping properly the dune ecosystems, coastal barriers against erosion, or sediment replacement, should be implemented. To conclude, we have to preserve the valuable spaces and sources of coastal zones through sustainable management. To make our points more vivid, we demonstrate some examples from the Greek island of Naxos. We will visit the beach rock reef at Agios Bay, the eutrophicated Lagoon Alyki, Agios Prokopios salt pits and sand dunes where we have wastewater pollution, a case of coastal erosion at Hawaii Beach, and finally the well-preserved coastal area of Glyfada.
180,000 years ago was the last glaciation period of the Quaternary, and sea level was 120 meters lower than the present. Naxos was connected by land with other Cycladic islands, such as small Cyclades, Andros, Tinos and Mykonos. As the climate was gradually becoming warmer, sea level rose to its current level. From a geological point of view, the part of Naxos that includes St. George consists of granodiorite and alluvial deposits. The very existence of a beach depends on the balance of sediment input-output. Usually, the sediment input is provided by the transfer and deposition of materials that are produced by the inland erosion. Granodiorite is the main source of sand for the beaches of this area. On the other hand, winds, waves and currents can remove sediment from a beach. Anthropogenic factors can also disturb this balance. For example, inland constructions, such as dams, can reduce the amount of sediment that reaches the coast. Data coming from drillings of the area and their analysis provided information regarding the paleogeography of St. George Bay. About 6,000 years ago, the bay was semi-closed and much bigger, including the wetland that today exists as a lagoon. From an archaeological point of view, the ancient site of Iria was supplied through a port that was built in the bay. A surf zone, visible in approximately 45 meters distance from the shore, indicates the presence of a reef. In this case, this reef is made of beach rock. Naturally, beach rocks develop along a coastline where specific conditions, such as low relief, low wave energy, and presence of fresh water occur. Under such conditions, the materials of the beach can be consolidated by calcium carbonate cement, thus forming a beach rock. Ergo, this reef corresponds to the position of an ancient coastline about 3,000 to 4,000 years ago. St. George Reef is visible above surface when the atmospheric pressure is high and causes a static drop of the sea level. Actually, there are more series of beach rocks submerged deeper in the bay, indicating other ancient coastlines. In the western part of Naxos, many wetlands in the form of lagoons can be found. In this part of the island, sand deposits along the coast gradually developed into sand dune systems, creating a natural barrier. These sand deposits are created by waves and currents that gradually transfer and deposit the sand along the coastline. Such barriers separate the sea from the inland part of the coast, which, however, is lower than the sea level. These lowland areas got filled with brackish water, creating the coastal lagoons we see today. Alyki Lagoon is an important wetland of Naxos Island. It contains brackish water, as it accepts fresh water from nearby streams, and at the same time it communicates with the sea. During the summer it gets dry. The lagoon is subjected to multiple anthropogenic pressures. The wider area of Alyki is characterized by low relief, its larger part is cultivated, and the riparian zones has been limited. Due to fertilizers overuse, the lagoon suffers from eutrophication. Part of the lagoon has been artificially dried in order for the airport of Naxos to be constructed. Lately, the need of expanding the airport arose, which means that in the future the lagoon may shrink even more. The lagoons of Agios Prokopios are significant from an ecological aspect, and if they were properly preserved, they could be beneficial for local tourism as well. However, there are clear evidence of domestic pollution in the water. In this case, it is appropriate to suggest rehabilitation practices. The disposal of the waste should be done in a controlled and efficient manner to prevent further pollution, and, along with the gradual renewal of the water, the contamination of the lagoons so far could be slowly reversed. Also, special plantations, with purpose to decontaminate the soil surrounding the lagoons, could be established on the polluted sites. The morphology of this coast includes a sandy, low-relief beach seawards and a steep cliff landwards. Waves and currents carry the sand, altering its distribution along the coast and changing the morphology of the beach. Extreme wave events can cause the cliff to collapse and the beach to retreat. High-energy waves that reach the cliff result in excavation at its base. The excavation contributes in events such as landslides and rockfalls, consequently distracting the cliff, but also providing new material for the beach. In addition, Hawaii Beach is partially protected by beach rock formations that can be found underwater near the coast. In Hawaii Beach, active coastal processes are being studied. Poles have been placed along the base and the top of the cliff. By periodically measuring the exposure or bearing of these poles at the base of the cliff, it is possible to track accumulation or removal of sand respectively. Through this practice, some trend of retreating or progradation of the beach may be revealed. The poles at the top of the cliff are placed at a specific distance from the edge. As the cliff collapses, the distance decreases. By periodically taking measurements of the gradually decreasing distance between the edge of the cliff and the pole, the retreat rate of the cliff can be calculated.